first assessment, even though your little graded problem set will count as kind of a mini assessment there. Our main focus is on functions, and with the functions, we've done a few things. One, you need to know what a function is, and we'll go over that in a second. We've done a lot with function notation, with adding, subtracting, multiplying, not really dividing, because we're not really gonna do it, but you got the idea. We've done compositions, we've done translating functions, and we've done piecewise functions. So a lot of stuff. I tried once again, like I know this year is weird. I'm not gonna try to give you the tricky problems like maybe I wouldn't have passed. So I tried to make it a little more straightforward. So the main idea is you understand the concepts. The nice thing is you are at home. So if I say a translation, you can look in your notes, go for it. I do ask that you do not work together and you don't I get it. I use what's the thing, Photomath sometimes. I don't even think it will work for any of our problems because they're really set up. But please don't go into some sort of thing and just look up answers. That's why I need zero. So first thing I'm gonna do is start with some points. And we'll just go over the concept of what is a function, just to remind ourselves. Okay, so as of right now, that's just a bunch of points. So I'm gonna ask you some just basic questions. First question, is it a function? Can someone just yell out, yes or no?
Yes.
No. No.
I'm going no.
The answer is no. But we need to know what the heck are we looking for, because it's been a while, I feel like. These little breaks, it's killing me too. I can't remember what I did yesterday, never mind, 3 weeks ago. The answer is no, and here's what you're gonna look for. You are looking for any x's that repeat and have different y's. So just as a hint, look for repeating x's. Just look in the hall, make sure everything's okay. Everything's awesome. Okay, so we look for repeating x's. The most basic definition of a function is every x can only have one y. So if one x has two y's, it's out. It's not a function anymore. So that's something to just remind yourself if you forgot to look for. And then just some other things that we've gone over the words, but just to remind ourselves what the heck they mean. If I asked what is the domain, just make sure you know what domain means. The domain means all of the x values of that function. So if I asked what's the domain, you would literally just list the x values. You would say 3, -8, 9, 7. If 3 happens twice, you only list it once. So that would be the domain. If I said what is the range, you would just list the y values. So I just go through -4, 2. I don't need to list -4 twice. You just do it once, 5, 9. Okay, so those are just reminders of what domain and range mean. Domain is just the x values of that function, and the range is just the y values. I did want to do this last one because there are mapping diagrams on the exam. So I just want to write this as a mapping diagram. So I just want to remind you of what that looks like, because I think you have to read 1 or 2 of them on Thursday. So a mapping diagram basically just looks like 2 big bubbles, where one you're going to put the x's and one you're going to put the y's, when you put the domain, one you put the range. And you're going to map the x to the y. So I'm going to map 3 in the x's to -4 in the y. Okay. I'm going to map -8 to 2. Now, for 9, it's going to go to -4. I'm not going to write -4 again. I already have a -4 there. So I'm going to map it up to that. For 7, that's going to map to 5. And 3 also maps to 9. So I'll just throw a 9 in and go with that. So if I look at that, that looks all sorts of funky. If you're ever reading a diagram and you're like, there's too much going on, there's lines everywhere, feel free to write them as points. You can kind of go interchangeably between the two. But the big thing to look for with a mapping diagram, if it's asking you if it's a function, you're looking to see, does one x go to two y's, or does one x go to more than one y? So when you see an x with two branches, you would say no. So just as a reminder of what that looks like. Once, it's been a while, so I'm sorry, we probably did this like the second week of school. Now we're in the middle of October, and it's just the way things are spaced out, it's easy to forget. So that might be some stuff you wanna look back at. But that's just kind of the general easing ourselves into it. Does anyone have a question with what a function is? Beautiful. So then, I'm gonna kind of skip around, but we did a lot with function notation, so we'll focus on function notation next. And with function notation, we do functions. So I'm just gonna give you a list. I'll say f of x is 3x minus 7. G of x is 9 minus x. We'll do an h of x as well. So we need functions if we're doing something in function notation. And with those functions, we're gonna be plugging some stuff in. So the most basic idea is something like this. I'm just gonna continue my numbers, so I'll say this is 5. I might just say, what is f of negative 4? So that's kind of the most basic one. Okay. What function am I using? That's where the f comes in. It tells me I'm using the f function, and what am I plugging into it? So I just go back to my f function, where I see x, I'm gonna plug in negative 4. And then I'm just gonna evaluate that side. What's that gonna be, negative 19? You're done. So just as the most basic concept, what function am I using and what am I plugging in? Well, we know it's not gonna be that easy. So not only can we plug in numbers, we can plug in variables, we can plug in expressions, we can do all sorts of fun stuff. So let's look at an expression. Let's do g of 4x minus 9. Same concept, but we're now plugging in 2 terms instead of 1. So I'm picking the g function. I look back at it. It says 9 minus, just be careful, especially with subtraction. If we don't put parentheses, it tends to kind of mess us up. You're subtracting the entire thing, so you're subtracting 4x minus 9. And then as I simplify, I usually just kind of distribute that negative in just to kind of take care of my signs. And then I would get my final answer of negative 4x plus 18. Not much else you can do from there. It's perfectly fine to have an expression like that as an answer. And then one more thing I wanted to show you with just kind of general. Now that we can plug into functions, you can do things like add, subtract, and multiply them. So if I have something like this, just as a reminder of the setup. If you see that you're adding 2 functions together, I always like to rewrite it as f of 4 plus g of 4. That just makes a little more sense in my head to kind of split up the functions like that. Because then I can see, oh, I'm going to figure out what f of 4 is. What is f of 4? 3 times 4 minus 7, which is going to give me 5. I figure out what g of 4 is. That's just 9 minus 4, right? Which is, did I do something else? Oh yeah, I did. I wrote it differently, which is 5. And then I'm going to add them up. So make sure you're just going all the way to the end and simplifying as much as possible. But if you see something like adding, subtracting, or multiplying, there's no division on there. Just make sure you understand that you can split them up into 2 separate ones, find their values, and then add them together. Does anyone have a question so far? Okay, sorry, I'm just trying to get everything in, so we don't run out of time here. So let's think about kind of adding on to that idea of functions. And something else we did with them was called compositions. We've actually done that most recently, so that should hopefully be semi-fresh in your head. But once again, I haven't really seen you in a week, so I get it. What number am I on? So for this, we're gonna do compositions. I'm gonna use different functions, because I meant to use that H1 and I didn't, oopsie whoopsie. But I'm gonna say A of x is x squared plus 3, and B of x is 2x minus 7. You can use whatever number or letters you please. No one number 8. So for our composition, just as a reminder of how it's set up. We would say this as A of B of negative 3. And what this is telling us to do is work from the inside out, find B of negative 3, and then take that answer and plug it into A. So I always start on the inside. And I'm going to plug that into the B function. 2 times negative 3 minus 7. Oh, is that going to give me negative 13? So once I find the answer to B of negative 3, I'm going to plug that in the A function. And that would give me negative 13 squared plus 3. That's 169 plus 3 is 172. So that would be that one. So the idea of working from the inside out, so please remember that. Excuse me. Okay, so we'll do 2 more on that. Okay. So let's look at number 9, because not only should we be able to plug in numbers, we should be able to use variables as well. So just as a reminder, how else I can write this? I'm going to write an F. Get into the habit of writing F's all day. You can also write compositions in that form, where you have an A with an open circle B. That's just the same thing. So just make sure you know what that open circle means. It means we're using a composition. I always rewrite it as A of B of X. Makes more sense in the brain. And I'm starting from the inside out. So for B of X, I'm saying to myself, I can't really do much. Like, I'm not plugging anything in, I'm just figuring out what B of X is, and you just look it up. B of X is 2x minus 7. So now that we know that that's 2x minus 7, I'm going to plug that into the A function. So in the A function, that would be 2x minus 7 squared plus 3. This is a step you are going to see quite a bit of, so I just wanted to point it out to you. When you are simplifying and you see a binomial squared, just make sure you remind yourself that means you're taking 2x minus 7 and you're multiplying it by itself. That's a big step. If you just square everything, that's not going to work. If you do something else, that's not going to work. Make sure a binomial squared is multiplied by itself, and then you do your distributing. So that would give me 4x squared minus 14 is minus 28x plus 49. And then we have that plus 3. And then we can combine like terms. Don't get freaked out if you get like the answers aren't going to all be like nice, like 2. Like, no. When you plug in just variables or expressions, you're going to get that out. So just be aware of that. I know from experience and just general teaching, people tend to have test anxiety. So hopefully it's not as anxious since you're doing it at your house. But do just make sure after 70 minutes, the timer will be up and you cannot work on it anymore. Please don't open it, do something, and then get distracted, like for 20 minutes, like staring off into space or checking your phone or doing whatever. And then email me and a tizzy that you didn't have enough time. Concentrate for that time, and you should be good. You should have plenty of extra time, actually. So just as a heads up there. Let's try one more composition. Let's do this one. Actually, I'm gonna have you guys try it. So I can actually put my attendance in, and that gives you a better idea if you've kind of been following, and if you have any questions so far. So using those same A and B, you're gonna try number 10, and you're gonna do A of B of 3x minus 1. So why don't you try that one just for a minute or two, just to see, in general, have you been following what we're doing, or is there any question that's popping up as you've been working? Same. Alright. Ooh. All right, so let's look at that. Just that's a good kind of self-check. Are you following along? So what I would start with is B of 3x minus 1. So I look up a B function. We would have 2 times 3x minus 1 minus 7. That would give us what? 6x minus 2 minus 7, which is 6x minus 9. Okay? So that's kind of my first part. Now I'm going to take that and plug it into the A function. And what do we got? 6x minus 9 squared plus 3. So once again, you see this pop up quite a bit. You're going to square that binomial. It's kind of an awkward way to write it, but you get the idea. My 6s are looking crazy. Oh, golly. So that would give us 36x squared. 54 would be minus 108x plus 81 plus 3 for a final answer of 36x squared. This should have an x with it, sorry. Minus 108x plus 84. So can you do a quick check of that and see if you were on the right track? Does anyone have a question with number 10? Or with anything in general?
Is it all right if we simplify with GCF?
Yes, if you did that, that's fine. Absolutely. Any other questions? Fabulous. So there's a few other little, well, not little things, but there's a few other things on the exam. The first thing being translations. There's not like a ton of super specific questions. It's just knowing those general translations, whether things are moved up, down, right, left, stretched, compressed, flipped over the X or flipped over the Y. So for translations, is this my new marker or my old marker? Let's see. Oh, this must be my new one. That's a delight. Translations, I might say something like, hey, the parent function is y equals x squared. If I gave you the function y equals 2 times x minus 4 squared plus 11, what's the translation? So you would just go through and say, okay, what does each part mean I'm doing? If you have a number in front, that's either a stretch or a compression. If the number is greater than 1, we say that's a stretch. If the number was less than 1, like a fraction or decimal, you would say it was compressed. So we're just going to say a stretch. You can say a 2, doesn't really matter. Then you would look inside your parentheses and you would say, in the function I'm subtracting 4, that means right or left. Remember to do the opposite sign, that means I move to the right 4. And then last I'm adding 11 outside of the function, so that means up 11. So just quick little things like that. It might ask you what different type of translations are happening. So you're just looking at the equation. I think there is one where it gives you like an absolute value. So it gives you, okay, this is the parent function. Well, we'll pretend that's the parent function going through 0, 0. And then it might move it like this. Basically, if you ever have something like that, you're just looking at the vertex. Did I move it up, down, right, left? I moved it to the left 3 and down 4. So I would write that like that. Once again, the nice thing is you can kind of look back and remind yourself as you're working. You should have some good stuff written down about that. But in general, it's just either looking at an equation or looking at a graph and just seeing how it moved in general. But nothing too crazy there. Are there any questions on translations? All right, I have 2 more things I have to do. All right, so the last section was on piecewise. Our good old buddy from a few weeks ago. So piecewise functions. Basically what that meant is if I give you a function, and there's different pieces for different parts of the domain, we call that a piecewise. Oops. Sorry, these take a minute to write, so that's why I'm trying to cut the rush here. There's just so many pieces. I don't even know what I just wrote. Okay, so we have a piecewise function. And there's kind of 2 different types of problems that you may see that have to do with piecewise. One will just have to do with evaluating, and then one will have to do with graphing. You are going to have to do a graph on the exam. That's why you're doing the orientation tomorrow. It will show you how to graph. It's pretty, like I went through it and I was like, oh, this kind of makes sense. You just have some points and you draw lines. It's nothing too exciting. On the exam, I think you only have to draw lines to make life a little bit easier. But for this example, we're just going to evaluate. So evaluate means if I said something like, can you find f of -3? And you would say, oh, of course I can. Like I'm just plugging into a function. The problem is you have 3 options. So the big thing is to check the domain first, figure out which one you're plugging into, and then plug in. So the big thing is just checking. So f of -3, don't just plug it in there because you see a -3, because that has a domain of less than -3. So that's not going to fit. So what I notice is I'm going to be in the second section because x is greater than or equal to -3. So it's just about plugging into the correct section. We're going to do the absolute value of -3 plus 1, which is the absolute value of -2, which is just 2. make sure you're actually do the absolute value. So just little things, making sure you're in the correct section, little things like that. So if I asked you, I don't know, what's f of 3, you would say, okay, I can do that. Just find the correct section, not in the first, it's not less than -3. It's not in the second, because it's not between those two, that interval, but it is greater than or equal to 2. So I'm gonna plug this one into that last piece. And then just do some evaluating. So we've done that a million times, I feel like. That would just give you 9 minus 9, which is 0. So you could do a bunch more. There's definitely one like that on the exam. So the big thing is just make sure you're in the correct section. Any questions? All right, I have one more problem. Sorry, I'm trying to get to this last one because I want to make sure you've seen it. Because once again, with all these nice little breaks we've had, it's easy to forget stuff. So I just want to remind you of how to graph a piecewise. Let me give you one that's not terrible here. If we get cut off, that's okay. I'll just kind of do the first step or two. Just to jog your memory. Okay. So we have this one. I didn't really feel like graphing those ones. So just as a reminder, when you're graphing, once again,
Good afternoon. A few quick announcements to BMS students.
No,
Girls
why
soccer
are you
practice
saying
is
that?
canceled today, all levels. Again, that's BMS. Girls soccer practice is canceled today, all levels. Also, remember students, remember to dress warmly because sometimes it's a bit chilly in your classroom, so please dress accordingly. And remember, attendance counts. Gotta be here every day, gotta log on.
all right, we
And
still
now
have to-
seniors are dismissed.
I just wanted to remind you to set up. We might not do the whole thing. So just as a reminder, when you're doing a piecewise function, you're going to be doing this on the computer. So please make sure you're doing your work somewhere else and scanning it in, because I can always give you partial credit. You kind of split up each section, and you're going to say, for this section, what should I choose as my x's? So this is telling me x is greater than 4. So I'm definitely going to choose 4, and then you choose something greater than 4 just so you have 2 points. You're going to find their outputs. In this case, the outputs would just be 5. And then just little things to remind yourself of when you're graphing, and these will all be options when you're doing it online. When you go to 4, 5, it should have an open circle there. So that's stuff I'm going to be looking for when you're graphing, that there's an open circle. And then you would put the 0.55 in. You would connect them with a nice ray in that direction. So that's your first part. Then you kind of go and say, all right, well, now we need to do the second piece. So you would do f of x equals 3 times the absolute value of x minus 2. You just want to find a few points. That's always your main goal for each section. I would choose -1 and 4. There is no absolute value tomorrow or whenever the heck you're taking it. But if there was, you would find the vertex as well, which the vertex of this is at 2, 0. Find your outputs, do your thing, go from there. And then for the last section, once again, find 2 points, plot them, just make sure your open circle, closed circle is on points. But once again, we kind of made it, it's hard doing stuff online and doing this, and graphing the pain. So we just made them all lines to make your life easier. But just as a reminder, since we haven't done those steps in a while, what you'll do, you're just breaking everything into sections.